Hi everyone, this is SINDHUJA Reddy, working as assistant professor at Marri Laxman Reddy Institute of Technology and Management, Dundigal. Today I am going to explain about the formal language and automata theory. So formal language and automata theory it will use for your GATE and GRE exams. So today I am going to start my first topic, that is introduction to finite automata. So here the introduction of finite automata. What is automata? Automata originates that automata it is came from the Greek word. It is came from the Greek word. It means the self-acting. It means the self-acting. Means here whenever we are using the finite automata, it will transmit the data from one transition to another transition. So here automata is also known as a abstract model. It is a abstract machine or model. Means suppose the abstract machine is nothing but it is like our electronic goods which is used in our homes, like washing machine, AC, laptops and everything. So here whenever we are using the abstract machine like washing machine, it will use the on and off button. On and off button. Whenever the client want to use that washing machine, he has to switch on the machine and he has to allocate the data to implement the action of machine. So here also the finite automata is the abstract machine. It will send the data from one transition to another transition. So this abstract machine is used on all the input strings. It is based on all the input strings. So the next topic in this finite automata, what is the definition of finite automata? What is the definition of finite automata? A finite automata contains number of states. So it will be represented. The finite automata is represented with the 5 tuples, that is Q. It will represented with the 5 tuples. It will be represented the tuples like I said, that is Q, sigma, delta, Q naught and final state. So this finite automata it will act as a machine, and as well as it has a number of states. It will be represented with the 5 tuples, or it will be defined as a 5 tuples. That is, the 5 tuples are Q, sigma, delta, Q naught and F. This finite automata is represented with the M. It is represented with the M. So this M. So here we have to know what is the 5 tuples. The first one is Q. The Q represents number of states. Next, sigma. The sigma is nothing but a input strings. Sigma is nothing but a input strings. Next, that is delta function. Delta function is nothing but a transition function. Transition function is nothing but it will transmit the data from one state to another state. The next one is Q naught. Q naught is a initial state. The last one, F. F is the final state. So here in upcoming classes, we are able to know what is state and what is sigma and what is the delta actual transition function and what is final state and what is how we are representing the initial state. So for example, here this is a transition diagram. Here we are representing with 1 and 0 the binary values, and we are using the alphabets A and D. Here we are sending the data from one state to another state. Here we have 2 states, that is A, B, and the another state is C. Here we are transmitting the data by using binary strings. So here we have to use only 0 and 1 because the programming language accept only binary values, that is 0 and 1. So how we are constructing the transition graph and how we are using, what are the process we have, those all things we represent. So here in this example, the first one the first state is A. It is enclosed with the circle. So the first state which is enclosed with the first state is not nothing but all the states which is enclosed with the circle. It is known as a state. So any states unna, it has to be enclosed with the circle. So it is a states, and what we can say states. The second one, to one state to another state, we are transmitting the data. We are saying we are transmitting the data. So to send the data from one state to another state, we use the transition like arrow mark. So ఒక స్టేట్ నుంచి ఇంకో స్టేట్ కి వెళ్ళడానికి we are using the arrow mark. So the next one, state అయిపోయింది, transition function అయిపోయింది. So next is the initial state. Next one is initial state. So what is initial state? The state which is enclosed with the circle. It will be represented with the arrow mark at the starting of the first state. Means the A is the first state. It will be enclosed with the circle. That is the state we know. So which is enclosed with the circle, it may be the Q0, it may be the A, it may be the 1, it may be the X0, all these things, it will be enclosed with the circle. It is a state. And the initial state always represented with the arrow mark for the first state. Arrow mark for the first state. Then the last one is double circle. So here we have the C is in double circle. Means it is a final state. It is a final state. So here we have learned the 4 things for this example. What is state? The state should be enclosed with the circle. Second one, transition function. The data should be transmitted from one state to another state by using arrow mark. The third one is initial state. The every first state, before the first state, the starting, we need to use arrow mark to mention it is a initial state, means starting state. The last one, fourth one, final state. The final state is enclosed with the double circle. It is known as a final state. So these 4 are the very important to build a graph, transition graph, to transmit the data from one state to another state. So here, next one is the model or structure of the finite automata. Model of structure, finite automata, or we can say finite state machine, or we can say finite state machine. So this finite state machine, it is divided into the 3 types. The first one is input tape. Second one is read head. The third one is finite control. So this model or the finite state machine, it is divided into the 3 types. The first one is input tape, second one is read head, and the third one is finite control. First one, what is input tape? Input tape. So this input tape is nothing but in this diagrammatic graph, we have one tape that is nothing but we can say building blocks. Building blocks. So what is the purpose of input tape? It has to read the every block or every cell. It is divided, the building blocks are divided into the individual blocks. Individual blocks. So the input tape is nothing but this input tape is a building block. This building block is divided into the small blocks or individual blocks. So this individual blocks is known as cell. Is known as cell. So this input tape is stored with number of digits and letters. So characters అని చెప్పొచ్చు. So in this input tape, it will be stored with the character. So the purpose of input tape is it has to be read. It has to be read or it has to be stored every cell with the string. Suppose I have taken the 4 strings, that is 1 0 1 0 1. So here we have the 4 characters which is in the numbers. So here whenever we are filling the blocks, we are filling the cells with the string, first we need to enter the first digit 0. After completion of storing the 0, then we have to move to the next digit 1. After that we need to go to the third digit and the fourth digit. After completion of all these string enter into the block, so the input tape is filled with the characters. So ikkada enti the input tape, it has to read the character by character into the cells which is in the building blocks, Then after the second one, read head. Read head is nothing but it uses the arrow mark. In our language we can say cursor. So this is a read head or read and write head type. Read or write head type అని చెప్పొచ్చు. So what is the purpose of it? This read and write head purpose, it will read the characters. From left to right. So this read head will use the every cursor for every bit. After completion of first bit, it will go to the second bit. Means our cursor is in 0. So the main purpose of this read head is it has to read the first character and it has to move to the next character and it has to move to the third character. After completion of the fourth one, the read head work will be stopped. Ante the input tape, the main purpose of input tape is it has to fill the building blocks with the characters. After storing all the characters, the read head has to be read every character from left to right. So after completion of reading, the last one, it is divided into the final control. What is final control? This final control should store all the data which is used in input tape and read head, which is like errors and the characters and the GBs, the memory, all the storage should be maintained by the finite control. Means it is like a memory to store every bit and every cell. After completion of finite state machine, this is a model of the finite automata, and in this we have to use this finite memory is the main. It will work as the heart of the finite automata. Means we have the CPU. The CPU is the heart of the computer, we can say like that. Here the finite control, it stores all the data, all the cells which is present in the input tape and finite read head data. So the next one is the structural representation of finite automata. So this structural representation of finite automata, so this finite automata is represented as two ways. It is represented as two ways. The first one is transition diagram, the second one is transition table. So before we are going to what is transition diagram, before we are going to know about the transition table, first we need to know what is transition diagram. Already I said we are using 4 types of process to construct any graph, that is state, transition function, and initial state and final state. So here the transition diagram, it will represented with states and transitions. So in this transition diagram, it will represented with the states and transition arrows. So here the nodes, each node in the set Q is a state shown in the circle. Means whenever we are constructing the graph or diagram, we have to show our state in a circle. Then the edges will be labeled with the edges, means the starting and the ending. The starting, it will be represented initial state, we use the arrow mark, and the edge we have to use the double circle. So the next is the start state. It will indicate arrow mark as a source. Already I mentioned the initial state is the starting state, and we can say source state. It will be represented with the arrow mark. The next one is last one, double circles. It is the double circle, it will be enclosed the state, and you can say as a final state. So here we can see the state will be represented with the enclosed with the single circle, and the final state it will be enclosed with the double circle. Then transition table. So this transition table, it will take the states and the symbols. It will take the states and the symbols. So it states in తీసుకుంటే and symbol తీసుకుంటది. So here whenever we are doing the transition table, the arrow should be, the rows should be states, and the column should be input strings. The input strings is nothing but a input strings. This input strings is nothing but a, it may be the 0, 1, and it may be the A, B. So here the rows should be, it will be represented with the states. So this states is nothing but a Q0, Q1, Q2, or capital A, capital B, and capital C. So here whenever we are writing this transition table, the row should be states and the column should be input state. The initial state should be marked with arrow mark. The initial state should be marked with arrow mark, and the star should be arrow. The star is a nothing but a, it will indicate as a final state. The arrow mark, it will indicate as a final state. So I can explain in a diagrammatic way. So A tends to A, whenever it is sending 1, it will be reaches B. Ante whenever the Q0, it will goes to the Q1. We can use in place of A, Q0, Q1, Q2. So Q0 of sending 1, it reaches to the Q1. Q1 of 0, from Q1 we are sending 0. So how we are constructing, how we are deciding this, all the states, how many states we require, all these things we can discuss later. So the next one is transition table. Before transition table, we have to know what is symbols and what is alphabets, and we have lot the language, clean closure, clean star, operations of string, all these things. So today we are going to only 2 definitions, that is symbols. So what is symbols? A symbol is nothing but it is a collection of letters and digits. It is a collection of letters and digits. Next, alphabet. An alphabet is a finite collection of symbols. Finite collection of symbols. Before alphabet, so the collection of letters and digits and Japan. So it is maybe the 0, 1, 2, 3 and so on. Next, digits is nothing but a, B, C, D, like this. Means letters is nothing but A, B, C, D, and the digits is nothing but 0, 1, 2, 3. So the collection of letters and digits is maybe the 0 and 1, it may be the A comma B. So the next one is alphabet. Alphabet is nothing but an alphabet is a finite collection of symbols. Means alphabet లో ఏముంటాయి, collection of symbols ఉంటాయి. It will be represented with the sigma. It will be represented with the sigma. Very important thing we are using in our problems also. In next class when I am explaining the problems, I will use this sigma very much. So an alphabet is a finite collection of symbols. It is represented with the sigma. And for example, whenever it is collection of symbols annam, so it may be the sigma is equal to A comma B, and the sigma is equal to 0 comma 1. Sigma is equal to A comma B comma and so on Z. So it is all lowercase letters and uppercase letters. All these things we used in the alphabet. So here what is A comma B and what is 0 comma 1? So always in flat we use only 0 and 1, which is a binary strings, So this is the 0 comma 1. The 0 comma 1 and A comma B, which is given in the two flower brackets, it is known as a set. Means here the alphabets is a collection of symbols and it is represented with the sigma. But we are writing our letters and digits in a flower bracket. So in this flower bracket, we are writing like 0 comma 1 or A comma B. A comma B. It will be represented with the sigma is equal to A comma B. So A comma B gani letters gani, it may be it is known as a, or else we can say it is known as a input strings which is passed through the directed diagram or transition diagram. So very important, you need to remember what is symbol and what is alphabet and how we are constructing the transition table and how we are constructing the transition diagram. Before I am completing this session, I am going to give some key points that what is finite automata, all these things. Finite automata is nothing but it is like a abstract machine which is doing work and it uses this on and off states. So we have the process, we have the four process, that is state, initial state, and final state and transition table. And the transition diagram, the state should be enclosed with the single circle. The transition diagram, one state to another state, it uses the arrow mark. And the first state, it uses before the first state we use the arrow mark, it is known as the initial state. And the final state, the double circle, it represents the final state. And the transition table, the arrow mark, the row should be the state and the column should be the input strings. So then next, the symbols, a collection of letters or digits. And what is alphabets? It is a collection of symbols. It is represented with the sigma. In this sigma, we can represent it with the flower brackets with 0 and 1 binary strings or A comma B. So this is known as a alphabets and we use in our problems. and this sigma is equal to a comma b. It is also known as the input strings. These are the key points in today's class. So thank you.